Hello everyone. In this video, I'm going to cover the concept for the third subtopic in chapter 3, which is the differentiation of trigonometric functions. So at the end of this lesson, you should be able to differentiate basic trigonometric functions, which are, first is sine x, and then the second one is cos x, and the third one is tangent x. So if you take a look in your notes, you are given the derivative of all 6 trigonometric functions, but I'm going to focus on the 3 basic trigo functions, which are these 3. So we are going to take a look at the first case. If you are given y or fx is equal to the simplest form, which is sine x, cos x, and tangent x, so what are the derivatives? So if you are given y is equal to sine x, then the derivative dy dx is actually equal to cos x. And if you are given y is equal to cos x, then your derivative dy dx will be equal to negative of sine x. And for the last one, y is equal to tangent x, then you will have your first derivative dy dx is equal to secant square x. So these 3 derivatives will be given to you without any proof, because the proof is not in your syllabus, okay, out of syllabus. So if you are still interested to know the proof on how do we get these derivatives, you can see me personally and I'll show you the proof. Okay. As for the second case, you are going to be asked on how to differentiate sine of u, cos of u, and tangent u. And please take note that here u is actually a function of x. Okay, so how do we differentiate this? Let's take a look. If you are given y is equal to sine of u, then once you differentiate, the derivative will be the same as previously. You are going to get cos of u. Please take note that the angle will stay the same. The angle will not be changed, okay? But in this case, since u is a function of x, then what you have to do is you need to multiply this by du by dx. We are going to differentiate the angle. So the concept here is almost as if we use the chain rule. If you recall, the formula for chain rule is dy dx is equal to dy by du multiplied by du by dx. And in this case, since I have y in term of u and we know that u is in term of fx, then this one is actually my dy by du multiplied by du by dx. Okay. Next, if you are given y is equal to cos of u, then the first derivative dy by dx will actually be, first we differentiate cos, you are going to get negative sine. The angle will follow u. And then multiplied by the derivative of the angle, which is du by dx. Okay. As for the third one, y is equal to tangent of u, then your first derivative will be dy by dx is actually equals to secant square u, because differentiating tangent you get secant square, the angle just follow, and then we are going to differentiate our angle giving you du by dx. Now what if your sine u, cos u, and tangent u comes with a power? In this case, we are going to take a look at the general form. Cos power of nu, sine power of nu, and tangent power of nu. If you are still confused, then the exact example I can give you is sine square of x square plus 2. Okay, in this case, you are going to have n is equal to 2 and my u is a function of x, which is x squared plus 2. So how do we define or how do we differentiate these functions? So let's say y is equal to sine to the power of nu. Then differentiating with respect to x will give us the derivative is equal to, first we are going to use the power rule. What we do is we take the power and bring it to the front, and that will give me n multiplied by sine power of n minus 1 u. Again, I repeat, the angle won't be changed. The angle will stay the same. And then after that, we are going to multiply this with the derivative of sine. So differentiating sine will give me cos, and again the angle will stay the same. and then we are going to differentiate our angle, giving me du by dx. So that is the final derivative, which is n times sine n minus 1 u times cos u times du by dx. Okay, what if you are given y is equal to cos power of nu? Again, we are going to use the power rule. So n will be taken to the front and your dy dx will start with n multiplied by cos n minus 1 u. And then we are going to differentiate cos, giving me negative sine. The angle will stay the same, u. And then we are going to differentiate our angle, giving you du by dx. And in this case, do not leave it like this. You need to take your negative sign to the front. Okay, so that will give you dy dx is negative n times cos n minus 1 u times sine u times du dx. Okay, the same goes for y is equal to tangent power of nu. We are going to take n to the front using power rule. So that gives me y prime is n times tangent power of n minus 1 u times differentiating tangent, giving me secant square u, and then differentiating u with respect to x, giving me du dx. And you can just leave it at that. Okay, so I'm going to show an example consisting of 3 different functions. And in this case, let's use a different pen, which is the green one. So example, for the first example, I choose y is equal to sine of 2x. In this case, my angle is 2x. So you have to be careful here. Once you differentiate, you are going to get y prime is equal to differentiating sine, giving you cos. The angle is still 2x, and then we are going to differentiate my angle. So we will need d by dx of 2x, differentiating 2x with respect to x, and that will actually give me cos 2x multiplied by 2. And we can just rewrite the constant 2 in front, so you get 2 cos 2x. And that will be my final answer. As for the second example, I need to differentiate cos, so I will get negative sine. The angle will just follow. So 2x plus 3 multiplied by the derivative of the angle. So differentiating 2x plus 3 with respect to x, and that will give me negative sine 2x plus 3 multiplied by 2. And again, I can just rewrite that constant in front. So negative 2 sine 2x plus 3. As for the last example, in this case, we are going to use the one in the form of y is equal to tangent power of nu, where u is a function of x. So here, once you differentiate, you are going to get y prime is equal to, we use power rule, taking 3 to the front, and that gives me 3 times tangent square of 5x minus 4. The angle won't change. And then I'm going to differentiate only tangent. Okay, d by dx, tangent 5x minus 4 with respect to x. And then multiplied by the derivative of the angle, which is 5x minus 4. And from here, you are going to get 3 tangent square 5x minus 4 multiplied by differentiating tangent will give me secant square. The angle will follow 5x minus 4. And then differentiating my angle giving me 5. From there, I can just multiply the 3 and the 5 together, giving me the final answer is 15 tangent square 5x minus 4 multiplied by secant square 5x minus 4. Okay. So what I want to remind you here is, please do your revision on the trigonometry chapter that we have covered in the first semester, because you are going to need all the formulas that you have learned previously. So please, I need you to do your revision. Okay. Thank you.